Hello Year 5. Here's a question for you. Have you ever wondered how a computer works? I hope so. I hope you've got the curious sort of brain that thinks those sort of questions. Because they're really magical things, but actually there's no magic involved. It's all down to programming. So you might have heard the word programming before, and programming just means making the programs that make computers run. So a computer program is a set of instructions, just like the ones we looked at last week. And these are called algorithms. That's the posh word for instructions that computers follow. This language tells the computer what to do. Programs have to be really precise because computers can't think for themselves. They're really good at following instructions, but only if the instructions are really good. If the instructions aren't very good, the computers won't follow them at all. Now, when somebody builds a program, they think about instructions and they break down the task into steps, just like you did last time. And the best programmers are the ones that can break it down into the fewest number of steps with it still making sense. Okay? Now, when we think about a program, we think about the task that the computer is going to have to complete. We think about the sequence. So we think about the order in which the computer will have to do things for it to carry out the task successfully. The computer can't think for itself. So we need to spell it out step by step in the right order. Now, if we get it wrong, the computer will follow the instructions and it will get it wrong too. It's really important. And when we're programming, sometimes we make mistakes, the computer makes mistakes. But we can fix those and make our program better by debugging. Now, here's a silly example. When you get dressed in the morning, you know what to do. You know you're going to put your underwear on first before you put your trousers on, otherwise you're going to look like a superhero and you might get laughed at. Okay? So you know that, but a computer wouldn't. If you said to a computer, get dressed, it might make that mistake without the step-by-step instructions. It needs that sequence to follow. Computers haven't got any common sense. They can't think. Not like you. They're just really good at following instructions. What computers are brilliant at, though, is following instructions and doing it perfectly every time. Computers will follow the same instructions over and over again. They will never make a mistake. Okay? If you asked me to do a really simple thing like pick up a pen and put it down 100 times, I might accidentally drop it, or I might not quite grab it off the table. But if you asked a computer to write the word pen 100 times, it would do it no problem. Really good at following instructions, even for simple tasks like that. And they don't get bored. A computer can do the same job all day long. If we think back to our inputs and outputs lesson, you've got the automatic doors. The sensor on the automatic doors is on all day, every day. And it's looking for somebody to come up to the doors. And as soon as it senses somebody, it opens the doors. And it will do that day in, day out, week in, week out, month in, every year, every 10 years, it will carry on doing that job. And it will never make a mistake. They're amazing at jobs like that. So let's think of a program, a little like we did last week with tidying our room. So we're going to do some instructions for a little sister to clean your room. So what we could say is, walk up to the toy on the floor, pick up the toy, put the toy in the box. 3 steps. But the problem is there's going to be more than one toy on the floor. So we're going to have to keep repeating those 3 instructions over and over and over again. Now what we don't want to do is keep repeating, walk up to the toy on the floor, pick up the toy, put the toy in the box. Walk up to the toy on the floor, pick up the toy, put the toy in the box. Walk up to the toy on the floor, pick up the toy, put the toy in the box. Even I'm bored and I've only said it 3 times. We're going to make it more efficient than that. So what we're going to say is right at the start, we're going to repeat these set of instructions until the floor is clear. Walk to the toy, pick up the toy, put the toy in the box. Is the floor clear? No. Do it again. Is the floor clear? No. Do it again. And you keep going until the floor's clear. So you can see that's much more efficient than repeating over and over and over again the same 3 instructions. We can just say keep looping until it's done. So I want you to think about the game Stuck in the Mud. Okay, so Stuck in the Mud is a game where some people are on and everyone else has to run away, and if you get tagged by the person that's on, you have to stop still with your arms out, and then if somebody runs under your arms, you're free again. And then the game ends when everybody is stuck in the mud. Yeah? Now I want you to think about a set of instructions for the person who's on, so the person who has to go and tag people to make them stuck in the mud. You could do it a long way, or you could be clever and you can have a repeating section and it'll be a much more efficient set of instructions. So, bronze, explain how computers follow instructions to carry out tasks. Remember, they can't think. So think about how they use those instructions. Silver, write your own set of instructions on how to play stuck in the mud for the person who's on. Gold, write those same set of instructions but include a repeating section to make it a more efficient set of instructions, a more efficient algorithm. And the challenge, think of a task that includes repetition and write your own set of instructions for it. Okay, so we've got algorithm, remember that's the word for instructions. We've got instruction and we've got repetition. Best of luck, guys. I'll see you soon.